Okay, let's begin. First question. Let's have a look at question A. We can move -15 to the other side and then divide both sides using a 3, right? So the original expression is equivalent to this one, 15 over 3, which is 5. Okay, so this means the difference of 2 and 7t should equal positive or negative square root of 5. Do not remember there are two solutions, positive or negative. Therefore, 7t should equal 2, positive or negative square root of 5. Then t should equal 2, positive or negative square root of 5 over 7. Then this is our final result. Any questions?
No.
Okay, then let's see the next one. Next equation, we can use quadratic formula to solve this, right? So first of all, because this equation is already in its standard form, then we'll identify the three coefficients. A is 3, and B is -I, and C is +4. Then let's calculate delta, the determinant, which is b squared minus 4ac, which is -I squared minus 4 by a, which is 3, by c, which is 4. Then -I squared is I squared. I squared is -1, right? Then minus 48, which will get us -49. Then x is given by this formula. Determinant, the denominator is 2a, which is 6. Then -b, which is I, positive or negative, square root of delta, which is square root of -49, which is 7i, right? Okay, then if we choose to use positive symbol here, we'll get 8i over 6, which is 4 over 3i. Or if we choose the negative symbol here, we'll have I -7i, which is -6i over 6. Then x is -I. So there are two solutions. One of them is 4 over 3i, and the other one is -I. Okay, I'll give you some time to have a look at this question and let me know if you'll finish.
Okay.
All right, good. Let's see the next one. Use completing the square method to solve the following equation. Okay, so this time, again, we need to practice completing the square method. So first of all, let's move everything to the left or to the right. So for example, we can move everything to the left. In this way, we'll have a positive leading coefficient. So it's better to move everything to the left. That means 5x squared plus 16x negative 10 equals 0, right? And this equation now is already in standard form, and we cannot further simplify this. But in order to use completing square method, usually I don't like leading coefficient to be a number other than 1. So we can divide both sides using a 5, right? So this is equivalent to the equation here. All right, so this time we have x squared, and we need to detach the second term to twice of x and then something, right? So apparently this should be 8/5. So we have a squared and 2ab. So this number here is our b, right? Then we can rewrite the equation as x plus 8/5 squared. Again, if you're not sure with the result here, you can always verify that on a scratch paper. So if we expand it here on a scratch paper, you can see we'll get x squared plus 2ab, which is 16/5x, right? And then plus b squared, which is 64/25. And we have x squared here, 16/5x here. First two terms are exactly the same. And because there is no such term here in the original equation, so we need to subtract it here. Subtract by 64/25. And then copy the rest of the equation, right? Which is -2 equals 0. And the new equation is equivalent to x plus 8/5 squared equals, then move all the constants to the other side, which is 64/25 plus 2. 2 is actually 50/25, right? Then we'll get 114/25. Okay, so this means x plus 8/5 equals either positive or negative square root of 114/(square root of 25), which is 5, right? Therefore, final solution is x equals -8, positive or negative square root of 114/5. So this is our final solution. Right? So please have a look at this and give you some time to make notes, and let me know if you finish. Okay.
Done.
Done. All right.
I'm done.
Okay. Next one. Use any method you like to solve the following equations. Usually, we'll choose the simplest method. Okay, that'll save a little time. So for the first equation, first of all, let's convert it to standard form first. That means the original equation is equivalent to this one. Move 8 to the left, it becomes -8, right? And for me, usually I don't like the leading coefficient to be a fraction, so I multiply both sides using 2. That'll give us x squared minus 6x minus 16 equals 0. Okay, now I think it's better to use the quadratic formula because it's very hard to factor this number and to come up with a number that is the number here in the middle. That means cross multiplication may not work here. So it's better to use the quadratic formula directly. So first of all, let's calculate delta. Delta is defined as b squared minus 4ac. Then we put every number in this expression. B squared is -6 squared, right? And minus 4 by a. A is the leading coefficient, which is 1. And c is -16. Then let's calculate delta. This is 36, then plus 4 by 16, which is 64, right? Then delta is 100. So 100, of course, is a perfect square, so we'll expect a rational number in the solution. X is given by the quadratic formula. 2a is the denominator, which is 2. Then -b, which is 6. Then positive or negative square root of delta. Of course, square root of 100 is positive or negative 10, right? And therefore, if you choose positive symbol here, this is 16/2, then x is 8. Or if you choose a negative symbol, 6 minus 10 is -4/2 is -2. So x can also be -2, right? Okay, so this is our final solution. X can be 8 or -2. Any questions?
No.
All right, next one, question B. Again, first of all, let's simplify this equation. First of all, we can expand the right side, which will have 5t squared minus 5t by -7, which is -35t, then plus 4, right? Okay, then we can move the 2t squared to the right side because in this way we'll have a positive leading coefficient. We'll move here, we'll get 3t squared -35t plus 4. So be careful with the expression here. Of course, you can move everything to the left, but in that way you will get -3t squared something, right? So usually I don't like the leading coefficient that complex. I want to keep it as simple as possible. So I move everything to the left, to the right. In that way, we'll have 3t squared, a positive leading coefficient. Then again, I think next step, we can just directly use the quadratic formula, which defined as b squared minus 4ac. Again, let's put all the values in. B squared is -35 squared, right? Then minus 4ac, which is 4 by a is 3. Then by c is 4, right? Okay, then we need to calculate 35 squared, which is 1225. Then subtract it by 48, which will give us 1177. Then you can try to factor 1177, which is actually not a perfect square number. Then t is given by this formula. 2a is a denominator, which is 6. Then -b, which is 35. Then positive or negative square root of delta, which is square root of 1177. So this is basically a final solution. Okay, I'll give you some time to make notes and let me know if you finish, okay?
Okay.
Okay, now let's have a look at question 4. What is the largest value of k such that the equation has at least one real root? Okay, so this is related to the determinant, right? Why it is called a determinant? Because the value of determinant delta decides whether the equation here has real roots or double real roots or imaginary roots, right? So let's go over this important concept again. So if delta is greater than 0, what kind of roots do we have? If delta is greater than 0, or if delta equals 0, or if delta is less than 0. First of all, if delta is greater than 0, we will have two different real roots, right? Can you recall that? And if delta is 0, we will have a double root. A double real root, which means two real roots of the same value. And if delta is less than 0, then we will have two different imaginary roots, right? Where two imaginary roots are conjugate to each other. You understand? We have already learned this, right?
Yeah.
Okay, so can you tell me in which situation we will have at least one real root? At least one real root.
Delta bigger or equal to 0.
Okay, delta needs to be greater than or equal to 0, right?
Yeah.
This is equivalent to at least one real root. Okay, so first of all, let's calculate what is delta in this particular question. Delta is defined as b squared minus 4ac. So first of all, we need to identify what are a, b, and c, right? So a is the leading coefficient, which is 3. B is the coefficient of x, which is -7. And c is a constant, which is 2k. So let's put all the values in. B squared minus 4ac is -7 squared minus 4 by a is 3 by c is 2k, which is 49 minus 24k, right? As we discussed, delta needs to be greater than or equal to 0. That means 49 minus 24k needs to be greater than or equal to 0, which means I'll put it here. 49 minus 24k needs to be greater than or equal to 0, which means or 24k needs to be less than or equal to 49, which means k needs to be less than or equal to 49 over 24, right? Therefore, we can make the conclusion. The largest value of k is k is less than or equal to. That means the largest value of k is, of course, value here, right? 49 over 24. Can you see that? Okay, I'll give you some time to have a look at this question and let me know if you finish. And I need to mention that, of course, you don't have to write these, right? This is how this helps you to recall the important concept in the quadratic formula, but you don't have to write all of these.
Okay.
All right, let's see question 5. Find all values of x such that the equation can be fulfilled. So usually to solve such questions, we can multiply both sides using the denominator here, right? But before we do that, we need to ensure that the denominator cannot be 0. Okay, so following this consideration, the original system is equivalent. First of all, the denominator cannot be 0, right? If we ensure the denominator is not 0, then we can multiply both sides using the denominator. So 4 equals 3x plus 8 times 3 minus 2x. Okay, let's check then if we can ignore this condition here. So let's check. If 3 minus 2x is 0, what will happen? If 3 minus 2x here is 0, then the right side is 0, right? And the left side is not 0. So of course, that means that x is not a solution of the second equation, right? So that means the second equation already implies that 3 minus 2x is not 0. Therefore, we do not need to write this condition in the next step. So this is just equivalent to 4 equals 3x plus 8, then 3 minus 2x. Then we can just expand it. Left side is still 4, right side is 9x, then minus 6x squared, then plus 24, then minus 16x. Okay, then this is equivalent. Let's move everything to the left, because in that way we'll have a positive leading coefficient, 6x squared, then 9x, positive 16x will give us 7x, then minus 20 equals 0, right? And now we only need to solve this new equation here, which can be achieved by using the quadratic formula. So let's find our 3 coefficients. Leading coefficient A is 6. Coefficient of x is b equals 7. And the constant c is negative 20. Therefore, delta is b squared minus 4ac, which is 49 minus 4 by a, which is 6 by c, which is negative 20, which is 49 plus 480, which is 529, right? And note here, 529 is actually 23 squared. Of course, you don't need to write this here in this step. This is just to give you a hint that in our next step, you can put something outside the square root, right? So x is given by this formula. 2a is the denominator, which is 12, and then negative b, which is negative 7. Then positive or negative square root of delta. As I said, square root of 529 is actually 23 squared, right? Of course, this is a perfect square number, so we can write 23 here. Therefore, if we choose a positive symbol here, we'll get 16 over 12, which is 4 over 3. Or if we choose a negative symbol here, we'll get negative 30 over 12, which will give us x is negative 5 over 2, right? So there are 2 solutions. One of them is 4 over 3, and the other one is 5 over 2. Okay, I'll give you some time to read this question and let me know if you finished, okay?
Okay.
All right. Then let's have a look at question 6. So quadratic equation, first quadratic equation has same roots as a second quadratic equation. What are the A and B? Okay, to facilitate our discussion, let's label the first equation with 1 and second one with 2. And let's use 2 letters to denote the roots. So let x1 and x2 to denote the roots of equation 1. Then we also know that x1 and x2 are also the roots of equation 2, right? Because they have the same roots. Then x1 and x2 are also the roots of equation number 2. Right? And because x1 and x2 are roots of equation 1, we know that x1 plus x2 must equal to something, right? Can you tell me what should I put here? You still remember that?
Negative B over A.
Yes, it's negative b over a, right? And according to equation 1, what is negative b over a? What is b?
It's 3.
This is our b, right? So b is 3. What is a?
1.
A is 1. Okay, this is according to equation 1, right? How about according to equation 2? According to equation number 2, what is b?
A. Oh, no, B.
Or uppercase b, right? And what is a in equation number 2?
A.
Of course, uppercase a, right? So in this way, we have a relationship between b and a. So similarly, there is another information we haven't used yet. That is the product of x1 and x2, remember? How about the product of x1 and x2?
C over A.
C over a, right? Okay, of course, c is the constant, right? So what is c? According to equation 1, what is c?
9.
9. What is a?
1.
A is of course 1. And according to equation number 2, what is c?
1.
Yes, it's 1. And what is a there?
A.
Capital A. Okay. All right. Then we have another relationship. Let's label them with 3 and 4. According to, apparently, it's better to solve equation 4, right? Because there is only one unknown quantity. So according to 4, we can successfully solve A is actually what? 1 over 9, right?
Yeah.
You see that? Okay, so let's
Yeah.
label this with 5. Then we can put 5 into 3 to solve B, right? Can you see that?
Yeah.
Okay, so what is B? If you put 5 into 3. Okay, let's write one more step. If you put 5 over 3, we'll get left side is 3, of course. Right side is B over A. So B over 1 over 9. Then we can solve B is actually which number?
Um. 9.
We can put this number to the left side, right?
Yeah.
So b is 3 by 1/9, which is 1/3, right?
Yeah.
Okay, then in this way, we have successfully solved A and B. Then we can make the final conclusion. Therefore, A is 1/9 and B is 1/3. Okay, I'll give you some time to have a look at this and let me know if you finish. And again, the key to solve such a problem is here. You need to remember the statements here, okay? If x1 and x2 are roots of a quadratic equation, we always have this relationship. Do not forget them. These are very important.
Okay.
All right, let's have a look at the next one. Question 7. Find the solutions of the system. This system consists of two equations. Usually we'll start from the simpler one, right? Let's label them with number 1 and number 2 in order to facilitate our discussion, right? So we can start from number 1. From equation number 1, we know that we can solve one variable in terms of the other, right? So you can solve x in terms of y or solve y in terms of x. I think it's better to solve x in terms of y. Otherwise, you will introduce fractions, right? So from 1, we know that x equals 3 minus 2y, right? And let's say this is number 3. Then we can put number 3 into equation number 2. And this will give us, okay, left side is x squared. X squared is actually 3 minus 2y squared. Then plus y squared minus 2y equals 6, right? And then let's simplify this new equation. So 3 minus 2y squared is 9 minus 12y, then plus 4y squared, then plus y squared minus 2y minus 6 equals 0, right? And then let's simplify. So first of all, 4y squared plus y squared is 5y squared. Then minus 12y minus 2y gives us minus 14y, right? And then 9 subtracted by 6 gives us plus 3 equals 0. Okay, now we only need to solve this equation here. I think it's better to use a quadratic formula, right? So first of all, let's calculate the delta. Delta is defined as b squared minus 4ac. Of course, you don't have to write this. This is only for you to remember this formula, right? So b squared is negative 14 squared minus 4ac, which is minus 4 by 5 by 3. Okay, then we'll have 196 minus 60, which is 136, right? Okay, so it's better to have a look at this number in at once to see if we can rewrite this as a product of some perfect square number. Of course, this is 4 by 34, right? And of course, 4 is a perfect square number. Of course, again, you don't have to write this in this step. This is only to give you a hint in the next step. All right, so y is given by this formula. 2a, which is 10, negative b, which is 14. Then positive or negative square root of delta, which is square root of 136. Because 36 is 4 by 34, so this is 2 times square root of 34, right? And simplified to 7, negative or positive or negative square root of 34 over 5. So this is our y. It has two solutions, right? So in order to solve x, we need to discuss separately. But if you choose the first value, that is y equals 7 plus square root of 34 over 5, then x is 3 minus 2y, which is 3 minus 14 plus twice the square root of 34 over 5. Then x is 1 minus twice the square root of 34 over 5, right? And do not forget, there is another possibility. If y is 7 negative square root of 34 over 5, then our x is 3 minus 2y, which is 3 minus 14 minus twice of square root of 34 over 5, which is 1 plus 2 times square root of 34 over 5, right? So as you can see, there are two sets of solutions. Now we need to make the solution. Therefore, the solutions are, okay, first set, if x is negative, well, 1, negative 2 square root of 34 over 5, then y is 7 plus square root of 34 over 5. Or the other set is x is 1 plus 2 times square root of 34 over 5. And y is at the same time 7 negative square root of 34 over 5. Okay. I'll give you some time to have a look at this question and let me know if you finish, okay?
Okay.
All right, let's have a look at question 8. One root of the quadratic equation where b and c are real constants is 3 minus I times square root of 3. What are b and c? Okay, so let me ask you a question. If all the coefficients, apparently a here is 1, right? And b is just b, c is just c. If all the coefficients are real, and we know one of the solution is 3 minus I times square root of 3. Can you guess what is the other root? Okay, can you give a reasonable guess?
3 plus I root 3.
Yes, and this is only our guess, right? So we need to verify or we need to prove the other root is indeed this one. So let's see if the equation is here. According to the quadratic formula, the roots is given by this formula, right? 2a, which is 2. Negative b is just negative b, and then positive or negative square root of delta, right? Delta is b squared minus 4ac. So 4 by 1 by c, it's just b squared minus 4c. Okay, if one root is 3 minus I times square root of 3. So there is an I, right? Apparently there is an I in one of the roots. So can you tell me, according to this formula, can I appear here? Can I appear here? Of course it can, right? Because negative b is a real number. Real number over 2 cannot appear I, right? There cannot be an I in there, right? You understand?
Yeah.
If you have an I in your solution, it can only occur here, right? If b squared minus c is less than 0, then we will have an I in the second part of the solution. Can you see that?
Yeah.
Okay, so if one of the roots is something negative, something I, according to this formula, the other root must be positive something I, right? Therefore, if one root is 3 negative I times square root of 3, the other root must be 3 plus I times square root of 3. That means the real part are the same with this one, and the imaginary part is just the opposite of the root, right? Do you understand?
Yeah.
Okay, so according to this analysis, the other root is this one. And again, we can use the important statements in the quadratic formula. First of all, the sum of the two roots is, tell me, what should I put here?
Negative C over A.
Negative b over a, right?
Oh, yeah.
Okay, so let's put all the values in. What is b in this particular problem? B is the coefficient of y, right? Which is just b. Can you see that?
Yeah.
What is a? A is a coefficient of x squared or m squared or y squared. Doesn't matter of the letters. It's the leading coefficient of the highest order terms, right? So what is a here in this particular question?
1.
1, right? Actually, I have written the ABC for you here. So A is 1. And can you tell me what is the sum of x1 and x2? If you know that one root is this one and the other root is this one, you can just simply add these two values, right? So that write it like this. These are the two roots, right?
Yeah.
Okay, so this means left side is negative b, then right side is how many? So this number cancels with this number, right?
So 0.
No, 3 cannot be canceled with 3. You have a
Oh.
plus sign here.
6.
6. Okay, so that means b is negative 6, right?
Yeah.
Do you understand?
Yeah.
Okay, so following this logic, how do we solve the value of a? We can use the product of x1 and x2, right? Product of x1 and x2 is, what should I put here?
C over A.
C over a. Okay, so back to this question. What is C?
1.
C is just C here, right? Which is the unknown.
Yeah.
And what is A?
1.
1. And can you tell me what is the product of x1 and x2?
C.
Okay, C, of course it is C, but in order to solve C, you need to know something else, right? So x1 and x2. So suppose this is x1, this must be x2. Does not matter about the order, right? You can also regard this is x1, then this is x2. Understand?
Yeah.
But if these two values are x1 and x2, then what is the product of x1 and x2?
It's 3 plus I root 3 plus, oh, times, never.
Okay, so can you tell me what it is? A plus b times a minus b. A squared minus b squared, right?
9.
Am I correct?
Yeah.
So 9 times minus 3i, just this is 3i squared, right? Then I squared is negative 1, so 9 plus 3. Understand? Can you see that?
Yeah.
Why it is 9 plus 3?
Yeah.
Okay, so 9 plus 3 is 12, right? So that means C is 12. Therefore, C is 12. Okay, any questions?
No.
Okay, I'll give you some time to take notes, okay? Let me know if you finish. And again, the key to solve this problem is, again, using this relationship, right? X1 plus X2 is always negative B over A, and X times X2, X1 times X2 is always C over A, okay?
Okay.
All right, let's see question 9. Again, in question 9, we are trying to solve an equation that contains the highest order of 4, right? We have never solved an equation directly that has a order of 4. The highest order we dealt with is something like this, x squared, right? So if we can reduce the number of orders, or to convert this one to something like this, we can solve this, right? So how do we achieve that? We can just let x squared equals u, right? Or if you don't like the letter u, you can use some other letters. For example, you can also use m, right? So tell me, if I let x squared equals m, the original equation, for example, equation 1, can be rewritten as well. So x to the power of 4 is actually to the power of 2, then power of 2, right? Then because I use a letter m to denote x squared, so tell me, what should I put here?
M
X
squared.
squared is m, right?
M squared.
So this is just m squared, right? You see that?
Yes.
In this way, you have successfully reduced the number of powers in the original equation to 2, which we have already know how to solve this. And how about the second one? -9 x squared. What is x squared now? X squared is m, right? You see that?
Yes.
So x squared is m. So let's put m here. Then plus 8, then equals 0. So first of all, we need to solve the value of m. As long as we can solve m, then we can solve the value of x. Understand?
Yes.
Okay, so the easiest way to solve this equation, to solve m here, is to use cross multiplication, because you can see here 8 can be factored to -1 times -8, right? Then -1 plus -8 will give you -9 here. Okay, so let's try use a cross multiplication. First terms m squared can be factored to m and m. Then last term 8 can be factored to -1 times -8, right? And then by use cross multiplication, we'll have -9, then -8m, which will give us -9m, which is exactly the same with the term in the middle, right? Of course, if you do not like cross multiplication method, or if you are not familiar with this method, you can always use the quadratic formula to solve m. Do you understand?
Yes.
Okay. Here, using the cross multiplication is just to save some time. Okay, so this is our first factor, m minus 1. And this is our second factor, which is m minus 8 equals 0. So tell me, what are values of m? Therefore, m can be, according to this equation, what are the values of m?
1 or negative
1 or 8,
8.
right? Okay, so now we know the values of, but we know the value of m, then we can solve x, right? Again, we need to discuss, if m is 1, what will happen? If m is 1, we know that x squared is m, then actually x squared is 1, right? Therefore, x is what?
It's 1 or plus -1.
Yes, it has two values, which are positive or -1, right? And another possibility is m is 8. Then we know that x squared is m, which is 8. Therefore, x is how many?
Plus -8.
Square root of 8, right? Right?
Yeah.
And of course, square root of 8, we need to put 2 outside the square root, right? It's 2 times square root of 2. You understand? Okay, so
Yes.
these are the final solutions. And if you want to verify, note that the highest order of x is 4. Usually we'll have 4 roots, okay? So let's count +1, -1, +2 times square root of 2, -2 times square root of 2. There are 4 roots, right? Okay, I'll give you some time to have a look at this and let me know if we can proceed.
Okay.
All right, question number 10. Find all values of r such that this equation can be fulfilled. That, in other words, we need to solve this equation. I'll say, okay, so a natural way to consider this problem is to expand it, right? However, if you expand the left side, you will get something like r to the power 4, right? Which again, we do not know how to solve it easily. The shadow. Okay, so probably that will not work, right? And let's dig deeper to this problem. As we can see here, we have r squared plus 3r here, and then r squared plus 3r happened twice in the second part of this equation, right? So we can let a letter to denote this expression, right? For example, if we let letter u equal r squared plus 3r. So what will happen in that case? Then this equation, the original equation, is equivalent to which one? Can you tell me? How about the first expression within the brackets here? It becomes what?
U.
U, right? Then times
U plus 5.
u plus 5 equals 6, right? So this logic here, the source is to use substitution to reduce the number of powers in the original equation, because we do not know how to solve something like r x to the 4th or x to the 5th. We only know how to solve x squared, right? This is the highest order we can deal with. Okay, so the equation here, we can just expand the left side. Left side is just u squared plus 5u, right? And then we can move 6 to the left, which is -6. Then again, you can choose to use the quadratic formula to solve u, right? Which we have already know how to do that. And if it is a simple equation, try use try using the cross multiplication first. If you try the cross multiplication, u squared can be factored to u by u, right? -6 can be factored to -6 times +1, right? Or 6 or +6 to the -1. By cross multiplication, we'll have 6u minus u, which gives us 5u, which is the term right in the middle, right? So therefore, this expression here is equivalent to, this is the first factor, which is u plus 6. And this is the second factor, which is u minus 1, right? Which equals 0. So can you tell me what are the values of u? So either this one is 0 or this one is 0, right?
6 or -1.
So u is either -6, right?
Yeah.
Or u is +1, right?
Yeah.
Okay, if you know the value of u here, put it back to the expression here, then we can solve the value of r, right? Okay, so following the same logic as in the previous question, first let's discuss if u is -6, then what will happen? Then -6 equals r squared minus plus 3r. This is now another quadratic equation, right? Which means r squared plus 3r plus 6 is 0, right? Then we can solve r is given by the quadratic formula, which is 2a, which is 2, negative b, which is 3, positive or negative square root of delta. Delta is b squared, which is 9, minus 4ac, which is 4 by 1 by 6, right? Which is -3 positive or negative I times square root of 15 over 2. Can you see that? Do you understand?
Yeah.
Okay, then let's discuss if u is 1, then we know that 1 is r squared plus 3r. Then r squared plus 3r -1 equals 0. Again, r can be also solved by using the quadratic formula, which is 2 is the denominator, then -3 plus or negative square root of delta. Delta is 9 minus 4 by a, which is 1, by c, which is -1. Then r is -3 positive or negative square root of 13 over 2. So there are, again, 4 solutions, which corresponds to the highest order 4. Okay, have a look at this question, and at the same time, I'll put my notes onto Google Classroom. And when you do the next assignment, if you need, you can always refer to my notes on Google Classroom, okay?